We live in a world absolutely saturated with information. It's just coming at us constantly, isn't it? A huge flood of data.
It really is. Overwhelming sometimes.
But imagine if we could take all that information, that potential, wealth of knowledge, and not just get swamped by it, but actually harness it, make real sense of it. Well, that's precisely the power and I guess the purpose behind data architecture.
Exactly. You can think of data architecture as the fundamental blueprint. It dictates how information flows and how it's managed within, well, any organization, really.
Right, the structure underneath it all.
Yeah, it's the structure that lets you turn raw data into something genuinely useful, into actionable insights.
And that's our mission for this deep dive, to kind of demystify data architecture, explore it in a way that's clear, but also hopefully pretty engaging.
Yeah.
Picture it like those architectural plans for a building, but instead of steel and concrete, we're talking about the flow of digital information.
That's a great analogy. And just like a building plan, understanding this blueprint means we need to look at a few key areas.
Okay.
We'll start with the foundational concepts, the real building blocks of data architecture. Then we'll look at how data is organized and how it, moves through different systems.
And we'll definitely need to tackle data quality. That feels vital. I mean, information's only useful if it's accurate, right?
Absolutely critical.
Yeah.
Then we can explore the different ways data gets stored and some of the more modern, cutting-edge approaches people are using now to manage this constantly growing resource.
Okay.
And it's key to remember, this isn't just super technical jargon for its own sake. It's about grasping how information starts, how it changes, and how it eventually becomes valuable.
Which ties right back to, our goal of understanding things quickly and thoroughly.
Exactly.
Okay, let's get down to that foundation then. You mentioned the data model is right at the heart of it. What exactly does that do?
So the data model, our sources describe it as a kind of map. It shows how different pieces of information connect and relate to each other.
A map, okay.
Yeah, going back to the house analogy, it's like the first sketches showing how the rooms connect, maybe where the main walls are. It's the conceptual framework.
So it lays out the relationships. Got it. And then there's the schema. How does that fit in?
Right, so the schema gives you the actual rules for organizing this data. If the model is the sketch, the schema is more like a detailed recipe. It lists the ingredients the data feels, but also tells you exactly how to combine them, how to structure them to get the result you want. The model shows what connects. The schema dictates how it's organized.
Okay, model connects, schema organizes. Makes sense. And then metadata. That sounds like data about data.
That's precisely it. Metadata is simply information that describes your data. The comparison to a label on a can is perfect.
Right.
Without opening it, what's inside, maybe the ingredients, the origin. Metadata gives you that essential context about the data itself.
Model, schema, metadata. Okay, that's our foundation trio. Now, how do we actually start, building with this? How is the raw data structured?
Well, the most common way to structure data, especially structured data, is using tables. Just picture a collection of related data, all arranged neatly in rows and columns.
Like a spreadsheet, basically.
Exactly like a spreadsheet you'd be familiar with. That's a fundamental unit.
Okay, tables. And what makes up these tables? What are the components inside?
So within each table, you have fields. These are the individual little pieces of information. Think of them like the boxes on a form. Each one holds a specific data point, like name or date.
Just one piece of info.
Yep. And then you have records, which are the complete sets of these fields for one single thing. So one whole row in the table, like all the info for one patient and their medical file, that entire row is a record.
Fields are the individual bits, records are the complete rows.
Gotcha. Now, how do we make sure each record is unique, especially if you have millions of rows? That's where the primary key comes in. It's a unique identifier assigned to every single record in that table.
Like a unique ID number.
Exactly. Think of your passport number or social security number. It uniquely identifies you. The primary key does the same for each record, ensuring you can pinpoint it precisely.
Makes perfect sense. The unique marker. And then we have foreign keys. That sounds like they link outside the table.
Spot on. A foreign key is a field in one table that points to the primary key in another table. This is how we actually build relationships between different tables, different sets of data. The example of referencing your spouse's info in your own record. That reference acts as a foreign key, linking your record to their complete record somewhere else. That's how we connect everything up.
So tables structure the data with fields and records, and keys identify and connect them. Okay? Now, how does this data actually get from, say, where it's created to where we need it for analysis? That's these data pipelines, right?
Correct. Data pipelines are basically the paths data travels along. They move data from the source systems to wherever it needs to go, maybe a database, a data warehouse, an analytics tool.
Like plumbing for data.
That's a really good way to think about it, yeah. Like a water pipe system.
Yeah.
The reliability of these pipelines is crucial for getting timely information.
And a big process within these pipelines is ETL. We hear that acronym all the time. Can you unpack that a bit?
Sure. ETL stands for extract, transform, load. It's a three-step process. First, you extract the data from its source.
Get it out.
Then you transform it. This is where you clean it up, maybe change the format, filter things out, make it consistent.
Prepare it.
Exactly. And finally, you load the transformed data into its target destination, like that data warehouse we mentioned. ETL basically gets the data ready for use.
The harvesting vegetables analogy really works there. Gather them, extract, wash and chop them, transform, then put them in the fridge.
Precisely. And often, you're not just dealing with one source. You need to bring data together from lots of different places. That's data integration.
Right, combining everything.
Yeah, it's about creating a unified view. Instead of looking at little separate pieces, you integrate them to get the whole picture, which often reveals insights you wouldn't see otherwise.
So data integration is like taking all those prepped ingredients and finally mixing them together for the finished dish. A single view.
That's an excellent analogy, but just having the data isn't enough.
Oh.
It has to be trustworthy,
Right.
accurate. How do we make sure it's actually useful?
Yeah. That brings us to data quality and the idea of data cleansing. Sounds pretty self-explanatory.
It mostly is. Data cleansing is basically finding and fixing errors, inconsistencies, duplicates, typos, cleaning up the mess in your data sets.
Washing the dirt off the vegetables, basically.
Yeah, removing the imperfections before you use it.
And then there's data validation. How is that different from cleansing?
Validation is more proactive. It's about setting up rules before the data even gets in, like checking that a phone number has the right number of digits as it's being entered.
So it stops bad data getting in.
Yeah, it's a preventative measure. Catching errors early means less cleansing needed later.
So cleansing fixes existing problems. Validation prevents new ones.
Okay.
And data profiling, that sounds like getting to know your data.
That's exactly what it is. Data profiling is examining your data closely to understand its structure, its types, its quality, any patterns or weird outliers.
Like taking inventory.
Yeah, like doing a full inventory of your pantry. Knowing exactly what you have, its condition, what you might need, it helps you manage everything else much better.
Okay, so we're extracting, transforming, loading, integrating, cleansing, validating, profiling. Wow, that's a lot just to get the data ready. Where does it end up? What are these storage places?
Right. There are different homes for data depending on the need. One common one is a data mart.
Data mart sounds smaller, more focused.
That's right. A data mart holds a specific subset of data, usually for a particular department or business function, like marketing or sales. Think of it like a neighborhood convenience store.
Got it. Quick access to specific things.
Yeah, tailored to local needs.
Yeah.
And then you have the data warehouse. That sounds like the big one.
The main depot.
Exactly. A data warehouse is a large central repository. It pulls data from many sources across the whole organization. Its main job is to support business intelligence, reporting, analysis, providing that single, consistent view of everything. The single source of truth.
Okay, the big central hub. And what about polyglot persistence? That sounds multilingual.
Sort of. It's a modern idea, really practical. It just means using different types of databases for different types of data.
Not forcing everything into one box.
Exactly. You wouldn't store soup and crackers in the same container, right?
Yeah.
Different data types often work best in different kinds of databases, relational, NoSQL, etc. Polyglot persistence is just about using the best tool for each specific data job.
That makes total sense. Okay, so we've got data stored in marts, warehouses, maybe other specialized databases. How do people find the data they need across all this? That's the data catalog, isn't it?
Absolutely. A data catalog is essentially an inventory or a directory of all the data assets an organization has. It provides descriptions, context, who owns it, how good the quality is.
Like a library catalog for data?
Precisely. It helps users discover what data exists, understand what it means, and trust that it's the right data to use for their purpose. It's key for finding your way around.
Makes discovery much easier. And data lineage. That sounds like tracing its history.
Exactly. Data lineage tracks the entire journey of a piece of data. Where did it come from? What transformations happened to it? Where did it end up? It gives you a full audit trail.
Like a family tree for data.
That's a great way to put it. It shows its origins and everything that happened along the way. Super useful for troubleshooting, checking quality, and meeting compliance rules.
Okay, so we've built the landscape, we know where things are, we can trace their history. But how do we make sure this whole thing is managed properly, securely, responsibly? That sounds like data governance.
Yes, data governance is absolutely crucial. It's the overall framework, the policies, the standards, the procedures, the controls that dictate how data is managed and used throughout the organization.
Like the Constitution and laws for data?
That's a very fitting analogy. It sets the rules of the road for everyone handling data, ensuring consistency, security, and compliance. It builds trust in the data.
And who are the people actually enforcing these rules on the ground? The data stewards.
Correct. Data stewards are individuals assigned responsibility for specific data assets. They act as guardians, making sure the data in their area is accurate, well-defined, and used correctly according to the governance policies.
Like park rangers for data domains.
Yeah, that works. They maintain the health and proper use of their specific patch of the data ecosystem.
And then there's data sovereignty. This sounds like it involves borders and laws.
It does. Data sovereignty is the principle that data is subject to the laws and regulations of the specific country or region where it's collected or stored.
Ah, so where you keep the data matters legally.
Big time, especially for global companies. You have to know which country's rules apply to storing customer data from, say, Europe versus the US. It's like rules about moving goods across borders, but for information.
Okay, fundamental concepts, governance. And now things are always evolving. What about some of these modern approaches we hear about, like data mesh?
Data mesh. That's a really interesting paradigm shift. Instead of a single central data team trying to manage everything.
Which sounds like a bottleneck.
It often is. Data mesh promotes a decentralized approach. Specific business domains like marketing, finance, logistics own their data. They treat it like a product they offer to the rest of the company.
So ownership closer to the source.
Exactly. They manage its quality, its accessibility, its life cycle, but within a set of globally agreed upon standards. Think of family members managing their own rooms, but still following overall house rules. It aims for more agility and domain expertise.
Decentralized ownership, federated governance. Interesting. And data fabric, that sounds different, more connected.
It is different. Yeah, data fabric is more of an architectural pattern. The goal is to create a kind of intelligent, integrated layer across all the different, often siloed data systems an organization has.
Like weaving it all together.
Precisely, like a spider web connecting everything, no matter where the data lives or what format it's in. It uses metadata, AI, automation to make data discovery, access, and integration much smoother across the whole landscape. It simplifies things for the users.
A connected, intelligent web. Got it. And data as a service. That as a service model is everywhere.
It follows the same logic. Data is about providing data to users or applications on demand, usually via the cloud, instead of building and managing all the infrastructure yourself.
You just subscribe.
You subscribe to get the data you need, when you need it, like tapping into a utility service, like electricity or water. It offers scalability, potentially lower costs, and faster access to certain data sets.
On-demand data. Efficient. Now, with all these moving parts, how do we keep an eye on things, make sure it's all working? That's data observability, right?
Exactly. Data observability is about having the tools and practices to actively monitor the health and performance of your data systems. Are the pipelines running? Is the data fresh? Are there quality issues popping up?
So more than just basic monitoring.
Yeah, it aims to give deeper insight into why problems might be occurring, not just that they occurred. Think of it like advanced sensors in your car telling you not just that the engine light is on, but maybe why low oil pressure, perhaps. It helps fix things proactively.
A health check system for the data ecosystem. Makes sense. And data architecture patterns, are these like standard blueprints?
Pretty much. They are proven, reusable solutions for common data challenges. Just like standard house layouts exist for certain needs, these patterns offer tested ways to design data systems for scalability, reliability, specific types of analysis, and so on.
So you don't have to reinvent the wheel every time.
Exactly.
Yeah.
Leverage what's known to work well.
Okay, we've talked about storing data, moving it, managing it. How do different applications actually talk to each other and exchange data in this setup? That's APIs, isn't it?
Yeah, absolutely essential. APIs, application programming interfaces, are like the messengers or intermediaries between different software systems.
The waiter analogy?
The waiter analogy is perfect. An API takes a request from one system, your order, delivers it to another, the kitchen, and brings back the response, your food. They define the rules for how systems communicate and share data, crucial for making everything work together.
The digital connectors.
Okay.
And data virtualization sounds a bit like magic.
It can feel like it. Data virtualization lets you access and query data from many different sources without physically moving or copy it all into one place.
So you don't need to consolidate it first.
Right. It creates a virtual layer that presents a unified view of the data, even though it's still sitting in its original locations. Think of looking through a window. You can see what's outside without bringing it all inside.
Like a virtual data warehouse.
In a sense, yes. It masks the complexity and lets users work with data from multiple places as if it were all together. Can save a lot of time and storage cost for certain use cases.
A unified view without the physical move.
Clever. Okay, so pulling this all together, data architecture is this vital blueprint for managing data effectively. Now, let's make this practical. Who actually provides the tools to build these architectures? Let's touch on the data architecture vendor landscape.
Right, this is where the concepts meet the market. And it's a busy market. Lots of companies offering tools for different parts of this whole process. We can kind of group them by what they do. Okay, where should we start? Maybe the foundation layers, the core storage like data warehouses.
Good place to start. These are the big storage facilities for structured analytical data. You've got major players like Snowflake, which is cloud native and known for flexibility. There's Google BigQuery, which is serverless and scales massively. Amazon Redshift is AWS's offering. And Microsoft Fabric is a newer, broader platform that includes strong data warehousing features.
These are the hubs for BI and reporting. And what about the data lake providers for all that raw data?
Exactly, the big reservoirs. Here you've got things like Azure Data Lake Storage from Microsoft, Amazon S3, which is object storage but heavily used for data lakes on AWS, and Databricks Delta Lake. Delta Lake is interesting because it adds reliability features like transactions on top of standard data lakes.
Okay, warehouses for structure, lakes for raw flexibility.
Yeah.
Now, how does data get into these places? The data movement vendors, the ETL and ELT tools.
Right, the data transportation system. For traditional ETL, extract, transform, load, you have established names like Informatica Power Center, SAP Business Objects, Data Services, and maybe newer ones like Stitch Data. They focus on transforming data before loading it.
Transform first, then load.
Yes. But then there's the ELT approach, extract, load, transform. Tools like Fivetran and Matillion are big here. They focus on loading the raw data into the powerful cloud warehouse or lake first, and then transforming it using the platform's own processing power.
Ah, load first, then transform inside the destination. Different philosophy.
Exactly. Leverages the cloud platform's muscle.
Got it. Now, shifting to those modern data architecture approaches, who helps build a data fabric, that connected web?
Several vendors offer platforms aiming for that data fabric vision. Informatica talks a lot about its AI-powered fabric. IBM Cloud Pak for Data is their integrated platform. And Talend offers unified tools that support building a fabric architecture. They provide the tools to weave it all together.
Okay, and the data mesh enablers, the ones supporting those decentralized domain teams.
Yeah, this is less about one single platform and more about tools and philosophies that help make data mesh work. ThoughtWorks consulted heavily on the concept. Companies like Monte Carlo focus on data observability, which is crucial for trusting data in a decentralized mesh. And platforms like Databricks can be configured to support domain-oriented data management within a mesh.
Tools to empower the domains. And finally, the data lakehouse vendors, bridging lakes and warehouses.
Right, trying to get the best of both. Databricks with its Delta Lake is a major proponent here, offering that single platform. Amazon Athena, querying data lakes, and Azure Synapse Analytics also offer services that blend lake and warehouse capabilities, making things more versatile.
So combining flexibility and structure really sounds like most companies would use a mix of these, right? Not just pick one vendor or one approach.
Oh, absolutely. It's almost always a hybrid situation. Organizations pick and choose based on their specific needs, what systems they already have, their team skills, the problems they're trying to solve. You might see a company using a data fabric to integrate things, while specific teams use a lakehouse within a broader data mesh concept.
Tailoring the toolbox to the job makes sense. Okay, wow, we've covered a ton of terms. Maybe we should do a quick recap of the key terminology, just lock it in.
Good idea. Our rapid-fire review. Data model.
The blueprint of relationships. Schema.
The rules for organizing. The recipe. Metadata.
Data about data, the label, ETL.
Extract, transform, load.
Data pipeline.
The path data travels, data catalog.
The data inventory or library catalog. Data lineage.
The data's history, its family tree, data mart.
Smaller, focused data store.
Yeah.
Convenience store. Data integration.
Combining data from different places.
API.
The messenger between systems, the waiter. Table.
Data in rows and columns. Spreadsheet. Field.
One piece of info. Record.
A complete set of fields, one row. Primary key. The unique ID for a record. Foreign key. The link between tables.
Okay, keep them coming. Index.
Speeds up finding data. Normalization.
Reducing redundancy. Tidying up. Denormalization.
Optimizing for faster reads, maybe adding redundancy back strategically.
Yeah.
Data cleansing. Fixing errors. Washing the data. Data validation.
Checking rules at the entry point. Preventing bad data. Data profiling.
Understanding the data's characteristics. Inventory check. Master data. Core business entities like customer or product. Reference data.
Standard codes and categories like country codes. Data steward.
The guardian for specific data. Park ranger. Almost there. Modern ones. Data mesh.
Decentralized ownership by domain. Data fabric.
The integrated web connecting everything. Data virtualization. Accessing data without moving it. Looking through the window. Ontology. Formal definitions for concepts. Shared vocabulary. Data sovereignty. Data subject to local laws. Border rules. Data as a service.
On-demand data. Polyglot persistence.
Using different databases for different data.
Yeah.
Right tool for the job. Data observability.
Monitoring data health deeply. Car sensors. Data governance framework.
The overall rules and policies.
Mm.
Constitution and data architecture patterns.
Proven solutions, standard blueprints. Phew. Okay, that helps cement things. Now let's try applying the Feynman way. Can we explain all this even more simply, assuming someone knows almost nothing?
Absolutely. The Feynman technique is all about simple explanations. So, boiling it down. Data architecture is the plan for how a company handles its information so it's useful and reliable.
Okay, simplest level, what is data?
Data is just recorded facts, little pieces of information, a name, a data number, a measurement. Think of tiny building blocks.
Like Lego bricks.
Yeah. Individually, maybe not much meaning, but when you put them together in the right way, like your name, what you bought online, and the price, suddenly it tells the story. It becomes a transaction record.
Okay, pieces of facts. And data storage. Where do these facts live? Simply put.
Think of different kinds of containers. Relational databases are like organized filing cabinets with linked folders, tables. Great for structured stuff like bank accounts. Non-relational, NoSQL databases are more like flexible storage bins you can toss in different kinds of info, like social media updates. Data warehouses are giant warehouses like for Amazon, storing huge amounts of historical data for analysis, like years of sales figures. And data lakes are like actual lakes you pour all kinds of raw data in, structured or messy, and figure out how to use it later, like a research hospital collecting diverse patient info.
Filing cabinets, bins, warehouses, lakes. Got it. And data flow. How does it move simply?
Think of water. Data ingestion is the water first flowing into the pipes, getting data into the system, like from your fitness app. Data processing is cleaning the water, standardizing addresses maybe. Data transformation is changing the water, maybe heating it or filtering it differently, converting currencies. And data delivery is the water coming out the tap where you need it, showing up on a dashboard.
Ingestion, processing, transformation, delivery, like waterworks. Okay. Data quality, why does it matter? Simply.
Is the information right and complete? Accuracy means your bank balance is correct. Pretty important. Completeness means a patient record has the allergy information crucial for safety. Consistency means your name is spelled the same everywhere. Bad quality is like a blurry mirror or a puzzle with missing pieces. You can't trust what you see or build with it.
Blurry mirror, missing pieces, good analogy. And data governance, simply.
It's the rules of the road for data. Access control is like having keys only the right people get into certain rooms. HRC salaries, you don't. Data lifecycle is deciding how long to keep things, keep tax records for years, maybe delete website logs sooner. Compliance is following the actual laws, like healthcare privacy rules, HIPAA. It's about being responsible.
Rules of the road, keys, knowing when to discard, following the law. Okay? And practical applications. How does this help in the real world? Simply.
Good architecture means better decisions. A restaurant uses sales data, business intelligence, to know which dishes are popular. A support agent sees your past calls, customer experience, to help you faster. A car company uses feedback, product development, to build better cars. A delivery company finds the best routes, operational efficiency. Using location data, it makes things work better.
Better menus, faster help, better cars, efficient deliveries, tangible benefits.
Exactly. Good data architecture gets the right info to the right people easily. When it's done really well, you don't even notice it. The information just is there when you need it.
It's the invisible plumbing making everything flow smoothly. So, wrapping up, data architecture really is that essential blueprint. It's how organizations make sense of this massive information wave.
Precisely. And understanding these core ideas, the concepts, the tools, the importance of quality and rules, gives you a really solid handle on how our digital world actually works underneath.
Absolutely. And maybe a final thought for everyone listening? Just consider all the data you interact with every day. Your phone apps, websites you visit, online shopping.
Yeah.
Think about how the underlying data architecture, how that information flows, where it's stored, how its quality is managed, is probably shaping your experience, often without you even realizing it.
It's definitely food for thought. The invisible structures are everywhere. We really hope this dive has been helpful and definitely encourage you to explore any bits that caught your interest further. It's a fascinating and ever-evolving space.